Hi everyone. This video will be a demonstration of the Microsoft Excel Solver tool. I'll be going through two examples on how to use this tool. So Solver is basically a function, a tool that determines the value you need to enter in one or multiple cells to produce a desired result in another cell. And Solver also allows you to enter constraints for your variable cells. I'm going to go into the data tab here, and over here in the analyze part of the data tab you may see solver. If you don't see the solver here, you can go into file and into options and then into add-ins. Now over here under manage you want to select Excel add-ins and click go. And from here you want to select the solver add-in and click OK. So for this example here, I want to know how many tickets I need to sell in order to gain a net profit of exactly $3,400. So I have the following information. I have the price per ticket, and the price per ticket multiplied by the amount of tickets I need to sell will give me the total revenue, which is in cell B3. I have the cost per ticket, which is how much money I need to pay in order to retrieve and to produce those tickets, which is $10 per ticket. And the total cost is determined by multiplying the cost per ticket by the amount of tickets that I produce. Over here, my constraint is that I cannot produce more than 400 tickets. Yet, I want to achieve a net profit of exactly $3,400. So I can go ahead and in cell B1, I can enter random numbers. But instead of doing that, instead of playing the guessing game, I'm going to be using the solver to help me out on this. So I'm going to go ahead into the data tab and launch the solver. So first of all, you're going to see it's going to say set objective. So in my case, the objective cell, the ultimate cell that I want to target is cell B8. That's the net profit. And what do I want to do to it? So I can either maximize it, I can minimize it, or I can enter an exact value. So in this case, I'm not trying to maximize or minimize my net profit. I'm trying to find out what value in cell B1 could give me a net profit of exactly 3,400. So I'm going to select value of, and I want cell B8 net profit to have a value of exactly 3,400. So I'll enter 3,400 over here. The next field is by changing variable cells. So how do I want to achieve this 3,400 net profit? In order to achieve this, the variable cell will be cell B1 because the net profit is directly dependent upon how many tickets I produce. So I'm going to select the variable cell, cell B1. Now, the next field is subject to constraints. So there is one constraint in my situation, which is that I cannot sell more than 400 tickets. So cell B1 cannot exceed 400. So I'm going to go to add constraint, and I'm going to select cell B1, and I'm going to say it has to be less than or equal to 400. So less than or equal to, I can select equal to, greater than or equal to, and I can do a few other things with this. But in my case, I want cell B1 to be less than or equal to 400. So I'm going to click add, and then I can just click cancel, and it'll take me back to the main screen. And then for the next solver parameter, it's going to select, I'm selecting a solving method for myself. So I can select GRG nonlinear. This is for smooth nonlinear functions. And it basically looks at the slope of a function and it determines the local optimum point. So it's one of the fastest methods and one of the most common methods. We have simplex LP, which is basically for linear problems. And we have evolutionary solving engine, which is for non-smooth problems. So in my case, and in most cases, GRG nonlinear is used. So I'll keep GRG nonlinear selected. And after that, I will click OK. And now it's asking me, do I want to keep the solver solution or do I want to restore to the original values? So yes, I want to keep the solution that solver gave me. So that's selected. And I'll click OK here. And as you can see over here, to achieve a net profit of exactly 3,400, I need to sell 340 tickets. Now, there's one more argument that I want to show you on the solver screen, which is one more constraint. So that constraint is that cell B1, which is the tickets to sell, it cannot be a decimal number. So I want solver to always give me a whole number in cell B1. So although it did give me a whole number this time, just in case, I can add another constraint and I can say cell B1 has to be an integer. This way solver will never give me a decimal number for cell B1. Okay, so I can click solve again and click OK. So as you can see, in order to gain a net profit of $3,400, we need to sell exactly 340 tickets. Now, this second problem is a workforce scheduling or staff scheduling situation. And in this scenario, my goal is to minimize total labor cost. So my total labor cost right here is in B12, cell B12. And over here, I have some information given to me. I know that for my office, there's the front desk, there's the stocking area, and there's floater positions. And I'm given weekdays from Monday to Friday. And for each day, it's counting the total staff depending on what numbers I put in these cells. And then it says minimum staff required per day. So each day there's a certain amount of staff that I need to have in total. And then it gives me the labor cost per day. So labor cost per day is taken by multiplying the total staff that day by their salary. So in my case, their salary is $15 an hour. So it's going to take cell B5, which is the total staff of that day, and it's going to multiply it by their hourly salary. So my ultimate goal is to minimize the total labor cost. And there's one more constraint I need to show you, which is that for each shift, so for front desk, stocking, and floater, for each of them, there's a minimum staff required per area. So for front desk, I need to have at least 2 staff available at all times. For stocking, I need to have 3. And for floater, I need to have a minimum of 1 person. And my fourth constraint, as I mentioned in the previous problem, is that all of these numbers, these staff values, have to be in integer form. I can't have half a staff member. So I'll go ahead and I'll launch the solver here. And my objective cell this time will be my goal cell, which is to minimize total labor cost. Total labor cost is in cell B12. So my target cell, my objective cell will be cell B12. And this time the question has told me that I need to minimize this cell. So I need to find the minimum value this cell can have given the constraints that I have and given the other information that I have. So I'm going to select min. And which cells do I want to change? Well, the cells that I want to fill by the solver are from cells B2 to F4, this entire green area. So I'm going to go ahead and select this green area. And then there are a couple constraints that have been given to me. The first constraint is that for each day, there is a minimum staff required number. So I can go ahead in this case and I can add a constraint. And so for each day, there's a total staff number, which calculates the total amount of staff that I have that day. So I can take this total staff row and I can say that it has to be greater than or equal to my minimum staff required per day. So when I do this, I'm basically saying that this has to be greater than or equal to this has to be greater than or equal to this this has to be greater than or equal to this, and so on, so forth. So I'm going to go ahead, click add. And my second constraint is that for each day I have a minimum staff required per area number. So for the front desk, each day there needs to be at least 2 employees. So I'm going to select this front desk row here, and I'm going to write greater than or equals to, and I'm going to select my constraint, which is this cell here. So that means that each of these cells over here, from Monday through Friday, for the front desk, have to be greater than or equal to 2. So I'll click add, and I'll do the same for the stocking. So I'll grab the stocking row, and I'll write greater than or equals to 3, and then I'll do the same for the floater. I'll select the floater row, and then I'll go to greater than or equals to 1, and I'll click add. And one more constraint is that I can't have a fraction of a worker. So I'm going to select this entire reference here, my variable cells, and I'm going to select int, which is for integer. So all of these have to be integers, and then I'll go ahead and click add, and I'll click cancel to take me back to the main screen. I'll keep it at grg nonlinear, and after this I'll go ahead and I'll click solve. I want to keep the solver solution, so I'll click OK, and there we go. So now I've determined how much people I need each day for each shift to meet my constraints and to generate the minimum total labor cost. So as you can see, for Monday in the front desk, I need 2 people. In stocking, I need 3 people. And for floater, I need 3 people. So it's meeting all of my constraints, and ultimately for that week, it's minimizing my total labor cost. So I hope you found this video helpful, and I'll see you on the next one. Thanks for watching.